Welcome to the Richmond County School System Teaching and Learning Content Corner with your teacher quality facilitator, Tiffany Leverett. The focus of today's bite-sized professional learning is Science and Engineering Practice Number 3, Planning and Carrying Out Investigations. Remember, science and engineering practices are the skills and knowledge required for scientists and engineers to investigate the world and design and build systems. The learning objectives for this video are as follows. Teachers will develop a deeper understanding of the Science and Engineering Practice Number 3, Planning and Carrying Out Investigations. Teachers will identify instructional strategies to support the targeted Science and Engineering Practice Number 3, Planning and Carrying Out Investigations. Although our focus is on planning and carrying out investigations, I would like to take a brief moment to remind you of all 8 science and engineering practices. Remember, these practices are designed to guide students to critically analyze, engage in argument from evidence, and obtain, evaluate, and communicate information. Planning and carrying out investigations are incredibly important in both science and engineering. In science, we use investigations to answer questions that we have developed on our own. In engineering, investigations are used to test designs that we have created. Investigations are important, but what comes out of investigations is data. Data can then be analyzed and used to reformulate questions and theories. The process of planning and carrying out investigations should always start with a phenomena. We should then allow students to use questioning to come up with many different explanations or explanatory models. Here is a checklist for conducting investigations. If you look, there are 2 parts to it. Carrying out investigations, where students are doing the experimentation, and before that, there is the actual planning. It is ideal for you as the teacher to put a stop sign halfway through the process. You want them to think about what kind of evidence they're going to collect. It is important for teachers to meet with the students and talk with them about their plan for 2 reasons. It is hard to come up with a good research question and safety. The worst thing that you could do as a science teacher is just say, here's the equipment. Go do the investigation. Good investigations investigate a phenomenon or design. Identify the evidence that will be collected, have a plan, collect evidence, and improve the design of the investigation. Before we take a look at the progression of this practice, I want to discuss how the Georgia Standards of Excellence for Science are designed. Notice the verbs obtain, evaluate, and communicate. These are the science and engineering practice that each of the Georgia Standards of Excellence in Science begins with. The standards also contain another separate science and engineering practice and a disciplinary core idea. This standard implements the science and engineering practice of planning and carrying out investigations. This is important because it gives context to science that students can use to help make sense of the world from a scientific perspective. Look at this slide. The obtain, evaluate, and communicate are color-coded. You also see that the science and engineering practice is in red and the disciplinary core idea is in green. The disciplinary core idea explains the what are students focused on. The science and engineering practice gives the how. How do students relate to the material? And the why is the phenomenon that helps students make connections to the world. Students in grades K through 2 will use the practice of planning and carrying out investigations to answer questions or to test solutions to problems that build on prior experiences and progresses to simple investigations based on tests to provide data supporting explanations or design solutions. Students in grades 3rd through 5th will build on experiences from K through 2nd grade and progress to include investigations that control variables, providing data, supporting explanations, or design solutions. Students in grades 6th through 8th will conduct investigations that use multiple variables and provide evidence to support explanations or design solutions. Students in grades 9th through 12th build on K through 8 experiences and progress to include investigations that provide evidence for and test conceptual, mathematical, physical, and empirical models. What are some good instructional strategies to effectively plan and carry out investigations in the science class? The following instructional strategies will be explored deeper in this video, which are using the cooperative learning strategy of assigning lab roles, using graphic organizers to conduct investigations, using the writing strategy claims, evidence, reasoning, or CER. Using the cooperative learning strategy of assigning lab roles involves putting students in small groups to complete investigations. Assign each student a job to do during the investigation. Model the job responsibilities before beginning the investigation so students understand what is expected of them while performing the investigation. Lab roles are a great way to help students stay engaged and work cooperatively during a lab activity. It is recommended that the lab team consists of 4 or fewer students. Here is an example of lab roles assigned created by the Richmond County School System Science Department. This resource is just an example, and of course it can be adjusted and modified to tailor the needs of your students and interests as well. This planning and investigations graphic organizer can be found at the Wonder of Science and is geared towards using with upper grades to collect and organize their thoughts and observations during investigations. This is another example of a graphic organizer that can be used while students are conducting investigations. The left side of this lab form should be completed prior to the right side. This is also a resource that can be found at the Wonder of Science website additionally. Anticipating these barriers in advance enables learning environments to be designed for accessibility from the start of the investigation. One barrier could be the classroom furniture, seating and spacing in the classroom, student cohesiveness, and accessibility to materials. But the main challenges faced in cooperative learning is group conflict or student cohesiveness. Students need to learn to work together. It is not always something that comes naturally. You can teach skills like praising others, taking turns for equal participation, and shared decision making. Expect the noise level in the classroom to rise during the activities, and be prepared to use conflict resolution checklists to resolve issues between 1 or 2 of the team members. Lastly, know what materials are available for students to successfully conduct the investigations and plan accordingly. The CER, or Claims, Evidence, Reasoning Strategy, is a writing strategy that can develop a student's analytical thinking and argumentative writing skills to turn that "I don't know" into a aha moment. In this video, Paul Anderson explains how the CER framework can be used to give explanations in a science classroom. In order to make a complete explanation of a claim, it must be supported by evidence and reasoning connecting the evidence to the claim. Additional resources can be found in the RCSS Canvas science courses and also in the Canvas Commons using the RCSS resources filter. If you are in need of any further assistance, please don't hesitate to reach out to the RCSS Science Curriculum Coordinator, your school's instructional specialist, or the teacher quality facilitator assigned to your school. Thanks for your time and continue to be scientifically fantastic.